Aboard the Barracuda, lids of ventilation pipes taken from the bow section are fitted with air hose couplings. The plan is to force compressed air into the tidal tanks to displace water and correct the list. The next morning, the bow section is under control and is boarded for final inspection. The first stage of this enormous operation has been successfully completed, and Smittock proudly raises the flag. With the Barracuda alongside to keep a constant air pressure in the ripped hull, the 107 tows the bow section safely away. The midsection will be raised by using a combination of shear legs, compressed air, and polystyrene spheres. The compressed air and the shear legs will give a controlled lifting. Because the polystyrene floats, inside the wreck it packs tightly from the top downwards, thus forcing out the water and creating buoyancy. But that is still a long way off. The crack, splitting the midsection from the aft part, will have to be completely cut through. Explosives are used to force apart the two remaining sections. Divers prepare to cut access openings for the polystyrene hoses and holes in the hull for the compressed air to escape during the raising. In Rotterdam, 200 tons of polystyrene is processed for the raising. The raw material, with a consistency of coarse sugar, is expanded by steam to form billions of tiny air-encasing spheres. These tiny objects will assist in lifting the midsection. The polystyrene is blown into a seagoing barge bound for Bantry Bay. At the same time, divers patch openings in the hull of the midsection prior to pumping in the polystyrene and air. It's a tricky job, at up to 40 meters depth in poor visibility. The barge carrying the polystyrene is brought into position over the midship. Hoses are rigged for pumping the spheres. The pumping starts. The pumping continues for 2 weeks. Finally, the required buoyancy is achieved. To be sure that all of the entangled wreckage between the two sections has been cut through, it is decided to use a heavy anchor chain to saw through any remaining bottom plates. The shear legs Tucklift 1 will do the job. Brute force and a delicate touch combine to rip apart the obstructing steel. The tonnage indicator shows a rapid fall-off in tension, which could mean success. Divers go down to check. The cut is clean. Now the chain is looped under the midsection to assist in the lifting. Air hoses are coupled. Compressed air is forced into the hull. The lifting of the midsection starts. After 7 months on the bottom, the midsection floats. Everything has gone according to plan. Tucklift 1 must use all her lifting capacity during the tow to shallow water. The Barracuda rides alongside, continuously pumping in compressed air to maintain safe buoyancy. Because of the tanker's tremendous draft and dangerous condition, a submersible pontoon is brought in to lift and transport the midsection out of Bantry Bay. After 3 months of patching, water is pumped out to raise the midsection as high as possible. It is discovered that a bottom plate is bent back like an open sardine can and hangs down 15 meters, making it necessary for the midsection to be loaded athwartships on the pontoon. At night, the pontoon is submerged and the midsection towed over into position. The next morning, the enormous structure is securely in place and ready to go. So far, so good. 2 down, 1 to go. But the next job will be more difficult than the 2 already accomplished combined. The aft, weighing 7,500 tons. At the Smittak office in Rotterdam, the salvage directors explained the planned operation to the representative of the West of England P&I Club.
That most of the tanks in the engine room are severely damaged. The amount of buoyancy which we need to lift this aft part cannot be created in the tanks which are left in the double bottom, even if we should fill them all with polystyrene or air. And that's the reason why our technical department with Mr. Van Wijk came up with this concept of 4 lifting barges, 2 hydraulic, 2 conventional ones with winches and tackles to raise this aft part of 7,500 tons with a total lifting capacity of 11,000 tons. But as you know, the aft part sunk in the mud 15 meters up till here. For this reason, we have to dredge around the remaining aft part in order to get the wires underneath.
Dredging continues for 30 days until 15,000 cubic meters of mud have been removed from around the wreck. At the same time, factories all over Western Europe are producing custom-designed equipment for the hoisting barges. Bow rollers, wires, sheaves, monkey faces, yokes, pulling shafts, winches, shackles, compensating wires, on such a scale as have never been used before on a salvage operation. All this equipment must be manufactured within 4 months. Hydraulic pulling machines of a unique design are also specially made for this final lift. Barge Giant 21, fitted with the hydraulic hoisting gear, underway to Bantry. 10 kilometers of high-tension steel wires are made to order, varying in circumference from 44 up to 100 millimeters. This sling has a breaking strength of 630 tons. It is 140 meters long and weighs 6.5 tons. On location, 3 sets of 8 slings are pulled underneath the wreck and connected up again to the 4 lifting barges. The 2 conventional winch barges and the 2 hydraulic hoisting barges, total lifting capacity 11,000 tons, safe working load, are anchored in position above the aft ship. One of the 24 slings which must pull the wreck to the surface is heaved in over the bow roller and secured to the pulling shaft. This shackle weighs more than 200 kilos. Not an easy job, working with such giant gear. With all the cables laid, the barges must be ballasted prior to hoisting. Steel plates are lowered into position between the wreck and the cables. When the barges start to pull, these plates will prevent the cables from biting into the weakened hull. Transducers are attached to the wreck to register all movement during the lifting. Zero hour. This is the climax of months of preparation. Everything is ready for the lift. The operation manager checks with each barge before the countdown.
21, zijn 22, Dering en Jasmin Turtle.
Zijn jullie klaar om te hijsen? Over.
21 is klaar. 22 klaar.
Ja, de Jasmin klaar om te hijsen. Dering Turtle klaar om te hijsen.
Goed, dan
5 seconden na nu gaan we hijsen. 1.
2, 3, 4 en nu.
"40 meters below, the wreck stirs in her muddy bed, and then, very, very slowly, starts her upward journey.
Hou jij onze rollen een beetje ook in de gaten zo. Dan kijken wij naar jouw rollen.
The shafts locked to the slings are drawn back by the specially designed pulling machines. Bogies on rails support the shaft's weight. There is no way back now. The 4 barges must hoist in synchronization to keep the wreck from sliding out of the slings.
21, 22, even opletten. En geef zo een seintje door.
In the late morning of the first day, the aft part has raised clear of the sea bottom. This allows the barges, with the wreck suspended beneath, to move away from the jetty and take up an ideal position for the remainder of the operation.
Jaap van der Meer op de 21. Hoeveel water heb je nog ongeveer uit te pompen?
Central Control monitors each barge.
Wie is 1 wat langzamer aan of 2 harder? Kijk maar wat je doet.
Both winch barges are equipped with 5 kilometers of steel wire.
Alle 2 kunnen ze weer draaien, Aap. Ze zijn precies gelijk.
Any minute now.
Hier allemaal bobbeltjes voor die bak.
The crewman reports the first sign of the wreck surfacing.
Wat hebben jullie er zo respectievelijk opstaan? Daring Turtle, wat heb jij erop staan?
De Daring Turtle 2280 ton. Jasmin digitaal 2290 en een kwartsgraad overstuurboord. Zijland 21 980 ton. 280 bar. Oplopend naar 300 bar is 1390 ton. 22 digitaal 1460 ton. Hydraulische druk 280 bar. Oplopend naar 285 is ongeveer 1225 ton.
Hoisting continues steadily. A team of tugs tows the partially surfaced aft ship between the barges to a sheltered anchorage in the lee of Whiddy Island.
Oké, wij vragen en Jeroen, deze positie blijven we. En dan zullen we kijken of we nog een beetje hoger op kunnen draaien.
Ja, opwacht Jeroen. Deze positie blijven.
Deze positie blijven, ja.
Cracks in the hull are patched so that the engine room can be pumped dry to create more buoyancy. Pumps are lowered inside the wreck. Slowly but surely, the combination of hoisting and pumping does the trick. This is the engine room. The aft section has been raised high enough out of the water to be able to carry on with the final stage. The semi-submersible pontoon, Giant 1, is again brought into position. The buoyancy chambers are flooded to sink her in 23 meters of water. With the two hydraulic lifting barges assisting to control stability, Giant 1 empties her tanks and slowly brings the aft section out, high and dry.
Barracuda roept ons, kan jullie ook?
It has taken more than a year and a half to raise the Betelgeuse. 573 days, non-stop, of skill, sweat, and guts for these men to accomplish the largest wreck removal of all time.